Hello friends, good day. Welcome to our YouTube channel GKR Soft. In this video, we are going to discuss about how to configure DEM events with counter based debounce mechanism. In our previous video, we discussed about how to configure DEM events with monitor internal. I have mentioned all my DEM related videos in the description. You can watch it. What is DEM? DEM is nothing about Diagnostic Event Manager. The main responsibility of them is to handle the event. Event is nothing about it's a fault. The fault can be reported by any application software component or any base software service software component. DEM will be tightly associated with DCM and NVM. What is event debouncing? The event debouncing, which is helpful for to confirm the event. Event debouncing refers to the process of eliminating multiple occurrences of a diagnostic event that are caused by a single physical event. There are three types of event debounce mechanism. One is monitor internal, another one is counter based, another one is timer based. In this video, we are going to deeply discuss about counter based debounce mechanism. And the monitor internal event debounce mechanism completely handled by the application software component. But counter based and timer based can be handled by them itself. Event status byte. Whenever the application software component or any other software component wants to report a fault, then they have to say about the monitor report status as well. So that means it's called as a event status as well via argument. We have a four options. One is DEM event status passed, DEM event status failed, DEM event status pre-passed, DEM event status pre-failed. So passed means report qualified test result passed. Failed means monitor report qualified test result failed. But pre-passed and pre-failed is non-qualified test result as pre-passed and non-qualified test result as pre-failed. But these two will be handled them internally. What is counter-based debounce? In counter-based algorithm, the DEM module provide an internal debounce counter for each individual event to qualify the reported event. So whenever the monitor reports as pre-failed, then the internal counter is increased by the increment step size. So if you will see this image, then you will come to know. So whenever the report happened as a pre-fail, then the step size will get increased. And if you will see, whenever the monitor reports as pre-passed, then the internal counter is decreased by the decrement step size. So from that, you will come to know now you have to configure a increment step size and decrement step size during your configuration. So when the internal counter reaches the failed threshold or the passed threshold, then the event is qualified as passed or failed respectively. So once the internal counter reaches the failed threshold, then the particular event will be stored in a event memory. So will be considered as a failed. But when the event reaches a passed threshold value, then the event is qualified as passed. There is a additional two configuration optional parameter is called as jump up and jump down. The jump down is performed if this condition is satisfied or fulfilled. The new report which is come to the DEM should be pre-passed. Then the last report should be pre-failed. At the same time, the incremented counter or internal counter value greater than jump down value. And jump up if you want to perform, then the new report is pre-failed and the last report is pre-passed and the counter value less than jump up value. But jump up and jump down is an optional configuration parameter. Based on the requirement, you can select it. These all are the configuration parameter is very important when you are going to select counter based debounce configuration or counter based debounce mechanism. So first you have to configure a debounce behavior, that generally a short name. Then you have to select decrement step size. So here for an example I kept as 5, but based on the requirement you can select it. Just for an example I am showing it here. And counter failed threshold. The counter failed threshold means if it will reaches the 5, that means the step size will increment one by one. So if the 5 times the report happens, then it will reach the failed threshold. So once the failed threshold value is reached, then the particular event will be considered as confirmed event. then that will be stored in the event memory. And you have to configure a increment step size. Here I have taken example for 1, and I'm not configuring a jump down, jump up. At the same time, I'm configuring count past threshold as -5 as well, because whenever you are going to select the counter pass threshold, that value should be in a minus. And the debounce counter storage, I really don't want it. And continuous also I'm keeping as false. Since jump down, jump up, I doesn't configure it. I'm keeping jump up value and jump down value as 0. But here the very important point what you need to consider is during your configuration, the increment step size and what is your failed threshold value, what is your fast threshold value, and the decrement step size as well. Everything, these all are the configurations are very important. If you will see this image is clearly explains about whenever you report the pre-failed, what will happen, whenever you report as pre-passed or whenever you report as a failed, then there is a possibility in counter based, you can directly report as failed as a event status also. At the same time, you can report passed also in the same. But in monitor internal, you are not allowed to pass event status as pre-failed or pre-passed. Only failed or passed is allowed. So here if you will see, whenever there is a pre-failed occur, how your increment step has occurred. At the same time, whenever the past is reported, how your step down activity is happening. If you will see the Autosar configuration in the case of counter based, so generally the software component will act as a client. That means here I have taken example, this is RT base software and this is your application layer. So in that case, your application software component will act as a client. Your DEM will act as a server. But at the reverse case of whenever you want to read a snapshot data, in that time your base software DEM is act as a client. An application software component will act as a server. This is I have taken one example for how exactly whenever you want to report from report a event, how the client server activity will happen. So in the case of reporting a DEM events, then you need a client server interface. I have mentioned Autosar videos also in the description. You can watch it. Then you will get a clear idea about how the communication will happen from application software component to DEM and how the interface, everything will be configured. Everything will come to know by watching my Autosar videos. Now, you want to configure DEM events because just now we have seen when you are selecting a debounce of counter based method, then what all are the needed configuration parameter you have to select. So here I want to say that if you want to configure a DEM event, then what all are the parameter you have to care about it. For an example, whether the DEM event available or not, then what is your event ID, then what's your event kind, whether this can be reported by base software or in application software component, and whether it will be available in variant, latch test failed, even created info port, you read it, you need it or not. Then very important thing is your DTC class reference. So if you want to map a DTC with a DEM event, then you need to configure DEM DTC class reference. And whenever you are selecting a DEM event, then you need to configure a event class as well. So in the event class, you have to say about whether the aging is allowed or not, and what is your event priority, whether you want to immediately store in the NVM or not, and what is your aging cycle counter threshold, and what kind of event significance it is, and operation cycle you can refer it, and aging cycle as well. In some cases, operation cycle also kind of aging cycle. So in that case, you have to refer it. And here you have to select which debounce algorithm you are going to choose. You can choose monitor internal or counter based or timer based. If you want to map a DTC with the event, then you need to configure a DTC class also. So here you have to say what is your DTC severity, whether immediate NV storage is needed or not, then what is the UDS DTC and your DTC attributes. In the DTC attributes, you have to say about what is your memory destination. So it can be a primary memory or secondary memory, or it can be a mirror memory. Already I have mentioned the video in the description about DEM memories. You can watch that video, then you will get a clear information about memory destination reference. But here the important thing is the DEM UDS DTC, because if you are creating a UDS DTC, then you have to mention your UDS DTC number in this column. This is an additional information I want to say. So how the DTC status combination, the possible DTC combinations whenever you are reporting an event. For in the case, first you have to understand it. In the default case, you always the bit 4 and bit 6 will set in the default case. So whenever you are not performing an event, and if you want to check the DTC status of your particular event, then in that case, the status byte will indicate 50. If it is test everything is passed, then 0. Then whenever the test is failed, then it will indicate 27 and 2F also. So only is confirmed it is set, then it will indicate as a 2F. So here some of the possible DTC status combination I have mentioned it here. Might be it's useful when you are going to handle the counter based or generally the DTC status byte combinations. And this isn't just an additional information. What is the meaning of every bit and what is the default value this will carry? As I mentioned, bit 4 and bit 6 as the default value as 1. I have done some testing scenario also. Whenever you can imagine you have configured a DEM event with counter based debounce mechanism. Then all your configuration is over and you have connected the ports. And when you want to report how exactly this will handle in the DEM event memory, you can imagine a situation. I'm starting ignition, so I flash the software and I want to report a DTC with the failed as event status, meaning I'm not sending as pre-failed or pre-passed. So I'm directly reporting as failed. Then I'm trying to read the DTC value. That means DTC status byte. So for that, I'm taking here the 19 service. There I'm choosing the subfunction is 04. Then I'm getting a response of 2F because I have configured a counter base, but even though I have passed the event status has failed, then this will be stored inside the event memory. Now I'm reporting in the same driving cycle, I'm reporting a DTC with passed now. Then automatically when I'm trying to read, then the value this will indicate 2E because the test failed bit, now it will become a false after reporting as passed. Now I am just stopping my driving cycle, meaning I'm doing a restart. Then I'm starting the next driving cycle. I'm trying to read the same DTC status. So here in the previous driving cycle, I already made it as passed. So when I'm reading, I'm getting the response as 6C. This is a one testing scenario. If you are handling a counter-based debounce mechanism, but you don't want to report as a pre-passed or pre-failed, then this is the way the report and the data will get stored inside the memory. This is another testing scenario which when you are passing as a pre-failed and pre-passed, then what will happen? I'm flashing the software. I'm starting the ignition, meaning I'm entering into the driving cycle. I'm reporting a DTC as pre-failed as many times to match with failed threshold value. In the same configuration, what I have shown in my previous slide. So there I have selected as the failed threshold value as 5 and my step size is 1. So in that case, I have to report a DTC 5 times. Then only the particular DTC will be considered as confirmed DTC and it will be stored inside the event memory. So after reporting 5 times, I'm trying to read the DTC status. So here I'm getting to know the 2F, meaning that DTC is confirmed, meaning the fault is accepted. And I'm reporting a DTC as pre-passed in the same driving cycle to match with past threshold value. Then I'm trying to read, then I'm getting 2E. I'm ending the driving cycle. That means I'm stopping the ignition. I'm starting the ignition again. I'm trying to read and I'm getting 6C. So this is the sample of the how the DTC flow or life cycle of DTC whenever you are choosing counter based and when you are passing as passed and failed or when you are passing as a pre-failed and pre-passed, how exactly this will work. That's what I have mentioned as a simple testing scenario here. But for the report of the test code, you can write it however you want. Hope you have a clear idea about how the counter based debounce mechanism works and when you are choosing a counter based debounce mechanism, how you have to do the configuration, everything. I hope you have a clear idea. Thanks for watching this video. If you like it, please share it with your friends. If you want to stay with us for more technical content, then please subscribe our channel. Thank you so much. Have a nice day.